Morning, friends. Welcome to the farm. So, yesterday I was still finishing work, so I couldn't post a video. I had lots to do, and I had a very busy weekend. So what I have done is, and something I was studying over the weekend when I had gaps, was the speed thing and gravitational pull and blah blah fish paste. And I had to view quite a few videos to actually, because my brain works very slowly compared, and I'm sure you science oaks understand that now. It takes me a while for this stuff to grasp. Okay, so basically, what I didn't understand was that the G force that's exerted when you're traveling at high speed, and it basically works out for every G that you're going, you get for every 1,000 kilometers that you're flying, you got like a G of force. So if you break in the sound barrier, you've only got like 1 or 2 G's that you're contending with. But the top G's that currently are enforced are around about 9, 10 G's. There's not much that could easily be from the Maverick movie, Top Gun. But the International Space Station spins at like 24,000, because anything that goes into orbit spins at 24 plus, I think it's 23 or 24,000 kilometers per hour, and that's the speed that it's traveling at, and that's like, my mind was like, how do you do that? How do you withstand so many G's? Because you see the guys passing out around about nine G's, they're fainting. They've got special pants on and everything, trying to handle these G's. And they don't make it. And the highest recorded G-force that any human has ever taken is 46 Gs, believe it or not, and he still lived. So when they revived him, he was still okay. I don't think he was okay, but anyway. So I want to explain to you how I understand it now, because once you go into, and there's still some things that don't make sense to me, but once you go into orbit, once you get into orbit, you go into like a free fall. And I don't understand how that free fall worked. But if you look at the planes, that they shoot a plane out into the sky, right, and they have people inside it, and while they're going up, everything's fine. They turn that plane around and they come down. When they come down, they get a zero gravity effect. So all the people sort of fly around and bash all over the place, and they're flying all over the plane. You can see them testing that. So they're saying the same effect happens when you hit orbit. You get that zero gravity, although you're traveling at that speed. So your ship's got to be able to handle it still, because you are falling at that speed. Okay, so there is a resistance, but if you're in space, there's not much air, so you don't have that wind like you are in an airplane. So have a look at this. So this is how I understand it now. I'm going to switch cameras around. Okay, so here we are. That's Earth. All right, and around the Earth is the orbit of the different satellites that are in different places, and the International Space Station, and so on. So what happens is, the guys will come up, they'll shoot out as far as they can, and they'll get into the orbit, and they'll start falling, if you know what I mean. So they're falling back to Earth. So as they're falling back to Earth, they keep in that orbit all the way around while they're falling back to Earth. So that's how it works. So you're falling into this, it's a free fall, and you get weightlessness and everything because you're in that, and you stay in it. And that's basically the thing that gets me is this section here to there. That section there gets me. So you've got to get to that speed. So you've got to climb up all the way up to where obviously the rim is, where you're going to start free falling from, that you can fall into space. And now if the International Space Station is here, you got to now find it, and now they're free falling as well at 24,000 k's. So you have to, everything has to be timed perfectly to get. So it's a hell of a lot of calculations, but that can be done, and that I understand 100% how the free fall works, and how they can spin at 24,000 kilometers around the Earth. Okay, so that all makes sense to me. But there's something that doesn't make sense to me. And this is now a little bit more difficult for me to try and explain to you, because I'm tackling these issues one by one so that I understand them. And with my childish brain, I can understand that does make sense. You can get around it. And I see the spin. I see that you're in zero gravity now, and you're spinning at that speed, okay? But getting on and off on an international space station will be a hell of a mission, because you need to get the people that have to time everything and get there exactly right. But the computer can work that all out, I presume. What I'm not getting is this, and this is something that this is frying my mind a little bit still. And everyone's telling me, and it's about the stars and the sun and the moon. Okay, so hear me on this. Every night, we're on the let's say the southern hemisphere. We're close to the equator, right? So we're on the outside rim of Earth, and it takes us a day to spin around. Okay, so we get our night and our day, spin around once, and for us to go around the sun, it takes us 365 point whatever. So it's so many days. It's a year. We go from where we are now, right around, we're back in the same place. All right. With the sun being where the pen is now, I'm going around, the pen, that kind of thing. So have a look at this now. This is what's confuzzling me. So if we've got the sun over here, right? And that's the sun. And here's Earth, over there. Okay. And we're slowly going around the sun. Okay. So that's 1 year. So I'm trying to read this end. And so here's our starting point, right? Now, we're on the equator. So during the day, I'm seeing the sun. All right? At night, I'm seeing all the stars over there. All right? So we'll go that side. I see the sun, the stars at night. I booger this side during the day, and I see the sun. It makes perfect sense, right? But now, in 3 months' time, I'm up here. I'm still looking at the sun during the day, but at night, there's different stars, surely. All right? Another 3 months go by. Here I am here. I'm looking at nighttime, different stars. But during the day, I see the sun because I'm rotating around the sun. Yeah, boy? You guys understand? Here we go, another one. I'm sorry, I know I'm sounding stupid here. There's different stars again that I'm seeing at night, right? And after a year, so we got here. That's 3 months, that's 6 months, that's 9 months, and we're back at 12 months or one at our starting point. And here we are back at the beginning, and we should be seeing all the same stars. So how does it make any sense to you? How does it make any sense to you that when I'm starting here, in 6 months' time, I'm still seeing the same stars that I'm seeing over there, but I'm looking that way. I'm looking away from the sun. I'm moving around the sun, and in 6 months' time, I am 180 degrees away from the sun. And I'm looking at nighttime, I'm looking at the stars that are above on the other side of the sun. But I'm seeing the same stars as what I'm seeing over there. That gets my mind. I am totally, my small little peanut brain does not fathom that. And they keep telling me, no, it's because the Milky Way and all this is so far away. It still makes no sense. And if you take those slow exposure pictures, we went to Swanee Pass and we stuck the camera up, and you look at those you get this twisting motion of the photographs of the stars. So they do these photographs of stars overnight, and you see the stars moving in a circle. So it shows that there is movement, right? Perfect. I've got no sock with that. But to me, it looks like we are spinning in a circular motion, but we're seeing the same stars. They might move a little bit around from one time of the year to the other time, but you still can plot your graph around wherever you're going. The sailors and ships do it. Where the stars are. The stars stay exactly where they are. So how can the stars stay exactly where they are? And we moving around the sun. It doesn't make any sense. Anyway, listen, I'm on 9 minutes. That is my controversial question. I've asked this before, and I can't get an answer for this. People keep telling me stuff that my brain is not getting. If I'm on the other side of the sun, and I'm looking away from the sun, everywhere, all the way around, I should be seeing different stars. So you tell me how that makes any sense, because that doesn't make any sense to me. So please help me out here, guys. And I'm not trying to, my brain doesn't get it. So help me, please. Okay, that's my 2 cents for today. Take care.